Hello everyone and welcome back in a new video. In this video we will explore the collapsed as-built analysis. It is also known as the but-for analysis. This method is one of the most recognized retrospective delay analysis techniques used in forensic scheduling and dispute resolution. So let's understand how it helps to determine what would have happened if specific delays had not occurred. Okay, so let's start. So first we have here the definition. You can see I have tried to add maximum details in these slides. If you will have any issue uh, learning from the explanation, so you can go through all these slides and I hope you will understand each and everything. Okay. So under definition, you can see collapsed as built analysis, also called but for analysis, is a retrospective delay analysis method. So the collapse as built analysis examines the actual executed schedule uh, as the as built, okay, and then removes identified delay events to simulate a but for scenario. So in simple terms, we ask what would the project completion date have been if these delays had not occurred? So it is a retrospective method best suited after project completions, especially when accurate as-built data is available. Okay. So next we have fundamentals, fundamental principle. The principle is straightforward. You can see the as the as-built schedule represents the actual execution of the project scheduling, including all delays. So the as-built schedule reflect everything that actually happened, including delays. So the analyst removes one or more delay events or fragment to simulate a scenario where those delay did not exist. So by comparing the actual completion date to the recalculated or rescheduled, but for completion date, so we determine the time impact caused by those specific delays. Okay, so I hope this is clear. So next we have when to use collapsed as built analysis. So this method is typically used after project completion when reliable and verified as-built data is available. So it is especially valuable in arbitrations, claims resolutions, or expert witness analysis. So when prospective techniques like time impact analysis cannot uh, longer applied. So this retrospective approach becomes ideal. So this is particularly effective when the as-built schedule is, you can say, well documented. Okay, so I hope this is clear. So next we have step-by-step methodology. So here we have some steps. So first we have obtained the verified as-built schedule contain all the accurate start and finish date. So we will start with an accurate and validate as-built schedule that includes all actual start and finish dates, yeah, progress updates, and recorded delays throughout the project. So this schedule must truly reflect what happened on site. Okay. So second, you can see identify the delay events and categorize them by responsibility. So we will list all the delay events that occurred during the project and classify them based on responsibilities, whether caused by the employee, contractor, or excusable factors such as weather or unforeseen conditions. Okay. So third, we have removed or collapsed the selected delay activities from the as-built schedule logically. So sequentially remove the chosen delay events from the as-built schedule. So these steps simulate how the project might have progressed if those specific delays had not occurred. Okay. So next we have recalculate the schedule to determine the hypothetical completion date. So after removing the delays, reschedule or recalculate the network logic to determine the new but for completion date, meaning the date the project would have finished but for those delays. Okay, so next we have compared the actual as built completion with the collapse completion. So we will compare the the hypothetical but for completion date with the actual project completion date to measure the total time impact of the remove delays. Okay, so this reveals how much each delay contributed to the overall project delays. Okay, so next we have the difference indicates the time impact of the remove delay events. Okay, so then next we have the document all the assumption logic changes and data sources clearly. So we will clearly record all the assumption, data sources, logic revisions, and supporting evidence to maintain transparency and credibility of the analysis. So proper documentation ensures the results are defensible and verifiable. Okay. So I hope step-by-step methodology is clear. Okay, so next we have as an example here. You can see as build completion date we have 10th October, then collapsed as build completion without employee delay 30th September 2025. Results the employee delays contributed 10 days to the overall project delay. Okay, so the project's as build completion was 10th October. After removing employee-related delays, the recalculated collapse as built completion become 30th September 2025. So this means the employer's action caused a delay of 10 days to project completion. So such clarity makes this method powerful in forensic and contractual evaluations. Okay. Okay. So next we have the strengths of collapse as built analysis. So this method is recognized and accepted by courts worldwide. Okay, so it is based on actual project execution, not assumptions. Okay, so it can be tested different scenarios where the delays were caused by the employer, contractor, or from the both sides. Okay, so it also provides quantitative and factual results. So that's why it is highly valued in expert forensic reports. Okay, so I hope this is clear. Next, we have some limitations. Here you can see every method has some limitations. So this is here we have some limitations for this method. So you can see here risk of the manipulation of the unrealistic activities are removed. Okay, so the accuracy of this delay analysis, depends entirely on the quality and logic of the as-built schedule. If unrealistic activities are removed, so the results can become misleading. Okay, so it cannot be used uh, prospectively and does not automatically consider concurrent delay unless they are analyzed separately. Okay, so therefore transparency and documentation are essential to maintain credibility. Okay, so I hope limitations and cautions are clear. Next, we have the reference standards. So here you can see I have added very important reference standards here. So the collapse as built analysis is endorsed by leading industry references, including AAC International Recommended Practice. You can see 29 hours 003. and Society of Construction Law Delay and Disruption Protocol, FEDEC Red Book, then ASCE delay analysis guidance. Okay, so following these standards ensures your analysis is both technically and legally defensible. Okay, so I hope this is clear. So here we have the summary. Okay, you can see here. By the way, we have all the things we have covered, but here we have the summary only. So in summary, the collapsed as built analysis is the retrospective, logic based, and credible delay analysis method. Okay, it helps to determine what would have happened, but for specific delay event using verified as built data. So when performed properly and in accordance with the AACERP 29R and the SCL protocol, it provides a transparent, factual, and defensible conclusion. And it is suitable for the professional, contractual, and legal proceedings. Okay. Okay, so I hope everything is clear related to the collapsed as build analysis. Okay, so thank you so much for watching this video. See you.